Okay, before we start the walkthrough for this worksheet, I'm just going to do a quick run through with you. The slideshow that you need to be on to learn molecular naming is slideshow 4, which is molecules, compounds, and naming. And in that slideshow, the actual naming part starts on slide 22. Now, there's still a lot of other very important information in that slideshow, particularly diatomic elements, which is something else that you have to memorize before we get to the point where we're writing the names, we're writing formulas to do chemical reactions. But just a quick run through, you're going to see the same things that I put in the worksheet to summarize it are in the slideshow, starting on slide 22. So here's the Greek prefixes you have to memorize. On the previous slide were some things that you need to be able to recognize to know if a compound is molecular. And then the rules, basically. The first name of the compound takes the Greek prefix. Unless it's only one, you don't necessarily need to say mono in the beginning, in the front of the compound. The second name will take a Greek prefix and you will change the ending. The ending's called the suffix to IDE, right? So NH3 becomes nitrogen trihydride, or you could also say mononitrogen trihydride. Um, again, it's more flexible on the mono if it's the first one, but we tend to say it on the second one. So for example, here now, water has only one oxygen. This subscript, you should know this from the chemical notation slideshow. The subscript is a number that is below the line. That's why it's called sub. And when it's on the right and below the line, it applies to the element it's to the right of. So this two means you have two hydrogen and one oxygen. So dihydrogen, two hydrogen, monoxide, one oxygen. And you'll notice here too that I didn't put two O's. I didn't put monoxide. I put monoxide. If you end up with two vowels next to each other, you're going to drop the vowel off the prefix. Somebody asked me about that in class, and it was a very good question. You do not want to drop the first letter of the element that has the vowel because that will make it so you can't tell what element it is. So that was a good point. So when you're looking through this slideshow, if you set it up like I have it set up right now, you go to, hold on, what is the setting in Google? The setting in Google is go to view and then go to slideshow. And that will allow you to actually click through the slides because I do have practice in here. So even though this is a heavy fluency unit, your application should still be there. You need to have application, you should be practicing. So here is us practicing going from a formula to a name, like N2O4. And then if you want to check if you got it right, you click on it. There, I even put the prefixes on the slide for you to keep it in front of you while you're practicing. There you go, dinitrogen tetroxide. I dropped the A off the tetra. Carbon tetrahydride, dihydrogen sulfide. You really could say also dihydrogen monosulfide. I tend to find that the reason why we drop it is whenever the mono seems like awkward for some reason, like monosulfide for some reason is more awkward than monoxide, which is kind of like flows. But I think it's fine if you put mono no matter where you put it. So on and so forth. That entire slide has practice. And then there are some reminders here about molecular naming. You're looking for compounds that are binary and contain only nonmetals. So it has to be both. Here you're going to practice writing the name again from the formula. And then here's all the answers so you can practice. Here you're supposed to practice if it's molecular or ionic. So you're going to need to make sure you remember that you have two things you're looking for. Two nonmetals, has to be binary, has to be all nonmetals. And so here we go through that. right? So it's pretty much at the end of the slideshow, and it's not very much because molecular naming is actually the easiest naming. It gets a little more complicated when we get to ionic naming. So this is the worksheet that we did in class. And if you were out or you want to go over it again, I'm going to run through everything very quickly in a video. So first things first, when I give you objectives, okay, I know you guys are like allergic to reading, but if there's a giant section at the beginning of this that's all written out, it's important. I don't write stuff out unless I think you need to read it. So please read. Your goals here are that you have to be able to use your knowledge of the periodic table to tell the difference between metals and nonmetals. If you can't, then you're going to have trouble putting things into categories, and then you won't use the right naming rules. So there's different sets of rules depending on different types of compounds. So you have to differentiate, tell the difference between molecular and non-molecular compounds using two basic criteria, which are in the worksheet. And the criteria, again, are it has to be all nonmetals and it has to be binary. We're going to talk about the difference between a chemical formula and a chemical name. And then we're going to learn how to name from a formula and use a name to determine what the formula is. So here again, in exercise 1 is your criteria. Your criteria is how do you know if it's molecular or not? If you decide it's not molecular, you are not allowed to use the same naming rules anymore. If you decide it's not molecular, the only other thing it can be is ionic, and that has a different set of naming rules, which is what we're going to do in the next video. And you did it in class actually today. So SO2 fits the criteria. It has two nonmetals, it's binary, and both are nonmetals. So that's a yes. N2O2, I have nitrogen and oxygen. That's two types of elements. That's what binary means. And both of these are nonmetals. So this is yes. Again, copper and chlorine. I do have only two types of elements here. The problem is that copper is a metal. And so this is no. It's not molecular. So I can't use molecular naming rules to name it. This one is NH4. Chlorine is the last one. Cl is one element. That has all nonmetals, but it's not binary. So no, it can't be molecular. So it's some other set of naming rules is going to be used for that. Here I have calcium, chlorine, and oxygen. This one kind of fails both tests. One, calcium is a metal. It's in group 2 all the way on the left and on the periodic table I'm talking about. And chlorine and oxygen, calcium, chlorine, oxygen is 3 elements, so that fails the test of also being binary. And last, carbon and hydrogen. These are both nonmetals, and there's 2 types, carbon and hydrogen. So it is binary. So yes, this one's molecular. So this is here because it's the first step in all naming processes. If you're going to name something or write a formula for something from a name, you have to know what type of compound it is before you start, because there are different rules for different types of compounds. So in order to make a good decision, you can't just start naming. You actually have to know what it is before you start. All right, exercise 2. We're going to go ahead. Why is my screen not moving? Okay, the next thing is you have to know the Greek prefixes. These you have to have memorized. Okay, so 1 is mono, 2 is di, 3 is tri, like 3 wheels on a tricycle, 4 is tetra, 5 is penta, then it's hexa, hepta for 7, octa, nona, and deca like 10 years and a decade. Very similar to the prefix. That's a Greek prefix we use in the metric system also, right? We have decameters. So same thing, deca means 10. All right, making good progress. Now, with these prefixes in front of you while you're doing the worksheet, you now can try your hand at writing names from formulas. So when you're writing names from formulas, you're going to go ahead and give both elements a prefix, depending on how many you have, and then the second element only. So when I say the second, I mean here's the first one, and here's the second one. We'll get the ending IDE. And there is really no way, no easy way to remember that, all the different, where to put the suffixes. The best way to do it is just practice a lot, and you're going to start to get the hang of where you put your "ide." Okay, I do have a list in some of the slideshows that help you with some of the trickier ones, because phosphide and sulfides, they get a little bit difficult for some people. That you know what, the more you practice, the more you're just going to get used to it. So this one is sulfur dioxide. Again, if you wanted to, you could change this to monosulfur. Okay, and oxide is oxygen, but oxygen, when I say the word oxygen, I mean the element. If I say oxide, I mean there is oxygen in this compound. Okay, chemical compounds are made of elements, but they don't behave the same way that the elements did when they were alone. And that's why changing the name is an important part of really making sure that people acknowledge that this is not free oxygen anymore. This is oxygen as it is part of a larger chemical. So I'm going to run through the rest of them. This is di-nitrogen, 2-nitrogen. And I'm reading that from the subscript. Dioxide. Again, I'm reading that from the subscript. Okay. Sulfur, I have 1. I could put monosulfur. I'm just going to put sulfur. I'm allowed to drop it, especially on the first one. And then I have 6 fluorine, so I'm going to put hexa for 6, and then fluor, and then at the ene, which is the second to last vowel, I'm going to change it to ide. Hexafluoride, sulfur hexafluoride. Sorry, guys, my stylus is not working, and so that makes my handwriting extra sloppy because I'm doing this with my hand, my finger. All right. Now the next ones are carbon dioxide, carbon tetrahydride, and dichlorine heptaoxide. Now we have to go in the other direction. Going in the other direction, I read the prefixes that are in the name. So this is a name. That's a formula. I'm going to read it, and then I'm going to decode that into a formula. Okay, remembering that if it's a prefix and it tells me how many there are, I'm going to write how many there are as a subscript, a little number down and to the right, of that element. So phosphorus comes first, and then chloride is chlorine, and there are 5 of them. So this is PCl5. Okay, sulfur, hexafluoride, S6, nitrogen, dioxide, 2 oxygen, dihydrogen, 2 hydrogen, monoxide, 1 oxygen. Phosphorus, just 1. Trichloride, Cl3. Okay. And let's move up. Last one is disulfur dichloride. So that's S2 Cl2. Okay, and last but not least, we're going to do practice. Again, this is what your quizzes are going to look like. It's just going to be one big page, pretty much, of tables. And the table will be, you have to fill it out. So whatever's blank is your responsibility. If you have a formula and the space next to it is blank, you're going to put the name. If you have the name and the space next to it is blank, you're going to put the formula. So I like doing it this way because I want you to get practice switching back and forth. You really have to be very fluid with this. So I appreciate that people don't want me to make you memorize a lot of stuff, but there really is no way to do chemistry without memorizing the elements. You will get to know them just from using them a lot, which is why I'm not necessarily going to quiz you this year on just the elements. But as you're naming, you have to get more fluid with them. Otherwise, you're going to find that every single problem just takes you forever because you're constantly looking stuff up, right? So the more fluent you are, the other thing is the more fluent you are, the less intimidating this is going to seem, right? If you know the words of another language, the language seems less threatening, like learning it seems easier. But if you don't know any of the words and then you have to make sentences out of them, you're really going to be stuck. So I think it's a little bit weird that people think you shouldn't have to memorize the elements. Of course you have to memorize them. You you have to in order to be fluent in the language of chemistry. So yes, I know chemistry is not going to be necessarily the end all be all of your life, but you definitely want to make this class go easier and feel less stressful. You want to work with chemical formulas as much as possible because a lot of times they just freak people out. So this is my version of what I would call exposure therapy. I want you to just be exposed to them a lot so that when you see chemical formulas and equations for chemical reactions, you're not freaked out by it. You're like, okay, well, that's just a chemical. I'll figure it out. All right, so N2O2, again, this is di for 2, nitrogen for nitrogen. You know what? I'm actually going to type this in because this is just, it's driving me crazy how messy this is. All right, so this is di nitrogen, di oxide. I'll put them in a different color. Okay, dinitrogen means that you have 2 nitrogen. Tetrafluoride means you have 4 fluorine. And on the computer, I can make these subscripts. So it's really important that you do write them as subscripts and superscripts, depending on what you're writing. So super means that you're putting it up high, sub means you're putting it down low. Right, this one is carbon monoxide. This one is dihydrogen monoxide. Good old water. Iodine heptafluoride is IF7. Hepta is 7. S4 is tetra sulfur. And Br6 is hexa. And then because this is the second one, I'm going to change the ending to ide. So this is hexabromide. Carbon tetrachloride is carbon. And then tetrachloride C lowercase l is chlorine. And then I have 4 of them. S2F4 is di for 2, sulfur for sulfur. F for 4 is tetra, and fluorine becomes fluoride. Dihydrogen. And then the second one, you could say monosulfide. You can also say sulfide. And this one is phosphorus. And then 5 is penta. And then this element, Cl. Please be careful, especially if you're inexperienced and you're not practicing your elements enough. This is an L. If you look very carefully, I purposely chose a font where you could see that it's an L and not a lowercase I. Keep in mind that a lowercase I will look like this with a little dot on top. Okay, so that's not an I, that's a lowercase L. And IDE ending for that chloride. Okay, right, and that's the whole worksheet. So molecular naming, it's pretty easy. Where this starts to get difficult is when you have to tell a lot of different types of compounds apart. And that's why it's really important that you understand why we're using these naming rules for these types of compounds. We're using Greek prefixes because these are molecular compounds. Ionic compounds is going to be a whole different set of rules. Right? Hopefully that video was pretty quick. We are all set to go.